I want to take you through a few application questions related to polynomials, specifically related to area and volume. So our first question has to do with a box that is being created from a square sheet of cardboard. And what we're going to do is we're just going to cut out all four corners, little squares that are x by x inches. And then we're going to fold up the sides to create a cardboard box and then find the volume of that box. So I realize that sometimes it's sort of difficult to visualize what's happening. So here is your visual aid. This is my 20 by 20 box. So this side is also 20. And what I'm doing is I'm taking out the sides of the box so that they are x by x. And again, that's all of them. They're all the exact same size. And what's left over, I'm then going to take, because all of these are now gone. This is cut away. And now I just have this shape that I'm going to fold up those four sides to create a box that sort of looks like this. Well, I know that when I fold this up, basically along this dotted line, that this height will now be x, this x distance. What I'm trying to do is I'm trying to write the volume of this box, but to find volume, I need this length and this width, and of course the height of x. Well, I know from the beginning that the whole side was 20, but I can't just put 20 here because I've now cut away x units here and x units here, and so really that distance is whatever's left over here. So to find that, we know that all of those add up to 20. So I could say that x plus y plus x equals 20. These two x's combine to give me 2x plus y equals 20. And then I would subtract 2x from each side to get that y must be 20 minus 2x. So this distance is 20 minus 2x. This distance is exactly the same. So this is 20 minus 2x, and this is 20 minus 2x. To find the volume, I would take the base of 20 minus 2x times the width, which is 20 minus 2x, times the height of x. And I'm very lazy and I don't want to multiply that out, but I am going to go ahead and make it look a little nicer by putting the x at the beginning and then saying that's 20 minus 2x quantity squared because I have two of them. So this is my volume function, is x times 20 minus 2x quantity squared. So back to the original question, I've really already done this one. We said it was x times 20 minus 2x quantity squared. That's the volume function. If I were crazy, I could go ahead and multiply all of that out, but it really doesn't do me any good because on my next question, they're telling me find the volume if that little x distance was 4. So essentially they're telling me x is 4. Because I took the time to write it out as v of x equals all of this, I can now just find v of 4 by replacing x with 4. And then following my order of operations. So v of 4 is 4 times the quantity of 20 minus 8 quantity squared. Again, keep this 4 on the outside because order of operations says I have to evaluate the parenthesis and then square it and then take it times the 4. So 20 minus 8 is 12. 12 squared, I'm going to move up here, 12 squared is 144. And then 4 times 144 gives me 576. And we are dealing with volume, and so we're dealing with cubic inches. This next one is an area question, and it's kind of the same idea. I did not create a visual aid for you on this one, but I've got a square piece of cardboard, and somewhere in the middle of that cardboard, I'm going to put a rectangular picture, and each side of the cardboard is x, so from here to here is x, The border that surrounds the photo is 3 inches on each side, so it's 3 here and here, and 4 inches on top and on bottom. And I am trying to find the area of the photograph. So the area of the photograph would be obviously length times width. And I don't know the length or the width of the photograph, but I do know that this whole distance is x, and that if I took away 4 and 4, that would leave me with whatever is left from here to here. So x minus 8 would be a good value for this side. This distance is 3 inches, and this is 3 inches. So from here to here, this would be x minus 6 inches, because I would take the 3 and the 3 away. So the area in terms of x would be the length and the width multiplied by each other. Again, feel free to FOIL this out if it makes you feel better about life, but I'm not going to because I'm lazy, and it's actually easier to compute if I leave it in this format. So to determine the area, if x is 12, then I'm finding a of 12, which means 12 minus 8 times 12 minus 6. 12 minus 8 is 4. 12 minus 6 is 6. If I multiply those values together, I get 24, and this is area, so it's 24 square inches. This last one is similar to the first question that we did, so press pause, do this question on a separate sheet of paper, and then press play to see how you did. We have a 10 by 16 piece of sheet metal. So again, a sort of visual aid if this is 16 and this is 10, and I'm cutting out those corners. Then what's left here would be 16 minus 2x, and this would be 10 minus 2x, and the height would still be x, just as it was before. So the volume of the box in terms of x is 10 minus 2x times 16 minus 2x times the height of x. And you could have the x in the front or at the end, it doesn't matter. The volume of the box, if each square is 2 inches on each side, essentially means I'm plugging in 2. So I'm taking 10 minus 2 times 2 times 16 minus 2 times 2 times 2. 10 minus 2 times 2 is 10 minus 4. This is 16 minus 4, and this is still 2. Evaluating 10 minus 4, I get 6. 16 minus 4, I get 12. And I still have the 2. And then multiplying, you can multiply that all in one step or one step at a time. 6 times 12 is 72, times 2 is 144. And so my answer is 144 cubic inches.